Now, in this lecture, we will find out the area of the semicircle using 4 different methods. In the drawing, we have a semicircle that is inscribed by triangle ABC. Triangle ABC is a right triangle. Angle ABC equals to 90 degrees. BC, side BC is equal to 5 units in its length. Side AB of the right triangle, triangle ABC, equals to 12 units in its length. And we want to find out the area of this semicircle that is inscribed by triangle ABC. So we will start with the first method. First of all, we will define the center of this semicircle as point O. And actually OB is the radius of this semicircle because of the fact that line segment OB starts from the center of the circle and ends at point B, that is the point on the circle itself. Therefore, OB is the radius of this circle. So we will define the radius of this semicircle as R. Therefore, OB will be equal to R. We will define the point of tendency of tangent AC with this semicircle as point D. Then we will join together points D and O by a straight line. And actually, line segment OD is also the radius of this semicircle for the same reason, so it equals to R. And here you can see that AB minus BO equals to AO. Again, AB minus BO equals to AO. I'll write it down. AB minus BO equals to AO. Again, AO equals to AB minus BO. So AO will be equal to AB is equal to 12 units. It is given us the question. And BO equals to R. It is the radius of this semicircle. So AO will be equal to AB, that is 12 units, minus BO, that is R. So AO equals to 12 minus R. So we can write here that AO equals to 12 minus R. In the next step, we will find out the length of the hypotenuse AC of the right triangle, triangle ABC. According to the Pythagoras theorem, we know that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So the square of the hypotenuse is AC squared. And it equals to the sum of the squares of the perpendiculars. That is to say, it equals to BC squared plus AB squared. I will repeat again. In the right triangle ABC, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, AC square equals to BC square plus AB square. That is according to the Pythagoras theorem. So AC square equals to BC square. BC equals to 5 units, so BC square is 5 square. 5 square is 25. Plus AB square. AB equals to 12 units, so AB square is 12 square. 12 square is 144. So we got that AC square equals to 25 plus 144 is 169. Here we will take a root out of this equation, equation number 1, and we will get that AC equals to the square root of 169, and the square root of 169 is 13, so we found out that AC equals to 13 units, so I'll write it here, that AC equals to 13 units in the drawing. AC equals to 13 units. And we have a rule, I will call it rule number 1. According to rule number 1, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. So I will read rule number 1 again. According to rule number 1, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. So what is the meaning of rule number 1? The meaning of rule number 1 is that if we have a circle and the center of this circle is at this point, we'll define the center of this circle as point O, and we also have a tangent to this circle here, actually AB, tangent AB is tangent to this circle at this point, We define the touching point between AB and the circle as point M. Point M, it is actually the point of tendency. We join points O and M together by a straight line. OM is the radius of this circle because of the fact that it starts from the center of the circle and ends at point M. That is a point on the circle itself, therefore it is the radius of this circle, so we'll define it as R, radius. And here, as you can see in the drawing, the radius OM is drawn to the point of tendency, that is to say it is drawn to point M, that is the point of tendency of tangent AB with this circle. Therefore, according to rule number 1, the tangent AB will be perpendicular to this radius. That is to say, this angle will be equal to 90 degrees and this angle also will be equal to 90 degrees. I'll repeat on rule number 1 again. A tangent to a circle, that is to say tangent AB, is perpendicular to the radius drawn to its point of tendency. So whenever you have a radius OM, like in this drawing, the radius OM, it is drawn to the point of tendency, that is to say it is drawn to point M, that is the point of tendency of tangent AB with this circle. Then the tangent AB will be perpendicular to this radius, that is to say this angle will be equal to 90 degrees and this angle will be also equal to 90 degrees. Okay? So we can actually can implement rule number 1 in our drawing, because in our drawing we have, first of all, you can see that CA is tangent to the semicircle at point D, so point D is the point of tendency of tangent AC with this semicircle, and actually the radius OD, it is drawn to the point of tendency, that is to say it is drawn to point D, that is the point of tendency of tangent AC with this semicircle. Therefore, according to rule number 1, the tangent AC will be perpendicular to this radius. That is to say, this angle will be equal to 90 degrees and this angle will be also equal to 90 degrees. Okay, because of the fact that the radius is drawn to the point of tendency, therefore the tangent AC will be perpendicular to this radius, that is to say this angle will be equal to 90 degrees and this angle will be also equal to 90 degrees. Okay, so in the next step we will prove that the right break triangle, triangle ABC, is similar to the small right triangle, triangle ADO. The small right triangle, triangle ADO, or the green right triangle, triangle ADO. Okay, we'll prove a triangle ABC is similar to the green triangle. So we will focus on triangle ABC and also on triangle, the green triangle, triangle ADO. And we will prove that those two right triangles are congruent, are similar to each other. Why they are similar to each other? Because first of all we know that those two angles, they are equal to each other, they are both equal to 90 degrees, so we can write down that this angle ABC, is equal to this angle ADO, and both those angles are right angles, so we can write down that angle ABC, triangle ABC equals to angle ADO, triangle ADO, and they are both equal to 90 degrees. And we also have a common angle. This angle is a common angle, it belongs to both triangles, so we can write down that angle A equals to itself. Angle A equals to angle A. It's a common angle that belongs to both triangles. I will repeat again. This angle A, equals to itself. Angle A equals to angle A is a common angle that belongs to both triangles. And also, those two angles, they are also equal to each other according to third angle theorem. So this angle, that is angle ACB, equals to this angle in the green triangle, that is actually angle AOD, and those two angles are equal to each other according to third angle theorem. So I'll repeat again. Angle ACB in triangle ABC equals to angle AOD in triangle ADO according to third angle theorem. So what is third angle theorem? Third angle theorem is that if two angles in one triangle congruent to two angles in another triangle, then the third pair of angles must also congruent. And here we found out that those two angles in triangle ABC congruent to those two angles in the green triangle, and according to third angle theorem, the third pair of angles, those pair of angles are defined as the third pair of angles, they must also congruent. Why? Because they are complementary to 180 degrees. Okay, so angle ACB equals to angle AOD according to third angle theorem. So we actually proved that all three angles in triangle ABC congruent to all three angles in the green triangle, triangle ADO. Therefore, we actually proved that triangle ABC is similar to the green triangle, triangle ADO, according to angle similarity rule. So we actually proved the triangle ABC is similar. This is the sign of similar to triangle ADO, according to angle similarity rule. I'll repeat again. Triangle ABC is similar to triangle ADO, the green triangle, according to angle similarity rule. So, what is angle similarity rule? Angle similarity rule is that if you prove that two angles in one triangle, angle similarity rule is that if you prove that all three angles in one triangle congruent to all three angles in another triangle, then you actually proved that the two triangles are similar to each other according to angle similarity rule. And from the fact that triangle ABC is similar to the green triangle ADO, we will conclude that CB over CA in triangle ABC, CB over CA in triangle ABC is equal to DO over AO in the green triangle. I will repeat again. From the fact that the triangle ABC is similar to the green triangle, we will conclude that CB over CA in triangle ABC is equal to DO over AO in the green triangle ADO. Okay? But what is the value of CB? You can see here that CB equals to 5 units. The value of CA is 13 units, we have already found out. That is equals to 13 units. DO equals to R, it is the radius of the semicircle, and AO, we already found out that AO equals to 12 minus R. So, in conclusion, according to equation number 2, we found out that 5 over 13 equals to R over 12 minus R. We will cross multiply equation number 2, and we will get that 5 times 12 minus R equals to 13R. Because multiply the equation number 2 and we got this expression. We will open the brackets on this side of equation number 2 and we will get that 5 times 12 is 60. 5 times minus R is minus 5R. And it equals to 13R. Here we will add 5R to this equation, equation number 2, and we will get that 13R plus 5R is 18R. So 18R equals to 60. Here we will divide equation number 2 by 18 and we will get that R equals to 60 over 18. We will divide this number 60 over 18 both the numerator and the denominator by 6 and we will get that 60 over 6 is 10 and 18 over 6 is 3. So in conclusion, we found out that according to equation number 2, R equals to 10 over 3 units. Now it is very easy when we know the radius of the semicircle equals to R over 3 units. It is very easy to find out the area of the semicircle, because the area of the semicircle is equal to pi r squared over 2 Actually, the brackets here, it is the sign for area. It means the area of the semicircle equals to pi r squared over 2. So it is pi and r equals to 10 over 3. Therefore, r squared will be equal to 10 over 3 squared over 2. So it is pi 10 over 3 squared is 100 over 2. 100 over 9. 10 over 3 squared is 100 over 9, all divided by 2. So 100 over 2 is 50 pi over 9. So we found out that the area of the semicircle equals to either 50 pi over 9 square units, or in terms of numbers, it equals to 17.45 square units. Okay, we finished with the first method. In the next step, I will present to you how to find out the area of this semicircle according to a second method. In the second method, I will present to you a new rule, and we will use the new rule that I will present to you in our drawing. But first of all, I will not repeat on the things that I did on the first method. We know here the center of the semicircle is at point O. AB equals to 12 units. It is given as the question. OB is the radius of the semicircle. AO equals to 12 minus R. We already did it in the first method. CB is given to us. It equals to 5 units. And we have already found out that AC, the hypotenuse of the right triangle ABC, equals to 13 units. And the touching point between AC and the semicircle is at point D, that is the point of tendency. OD is the radius of the semicircle, that is to say, it equals to R. We have already explained it on the first method. Okay, so I will present to you a new rule that is called rule number 2. It is called rule number 2 or two tangent theorem. Rule number 2 or two tangent theorem. So, according to rule number 2, the length of two tangents, the lengths of two tangents from a common external point to a circle are equal. So I will read rule number 2 again on two tangents theorem. According to rule number 2, the lengths of two tangents from a common external point to a circle are equal. So what is the meaning of two tangents theorem or rule number 2? The meaning of rule number 2 is that if we have this circle and we have also this point P is an external point of this circle. Why point P is an external point? Because of the fact that point P is not located inside this circle nor on this circle, but it is located outside of this circle. Therefore, point P is defined as an external point of this circle. So if from the external point P we will draw two tangents to this circle, so the first tangent will be this tangent, we will define the touching point between the first tangent and the circle as point A. Then we will draw a second tangent from the external point P to this circle. And we will define the point of tangency of the second tangent with this circle as point B. And according to two tangents theorem, the lengths of two tangents, the length of the first tangent is PA and the length of the second tangent is PB. And according to rule number 2, the lengths of two tangents, that is to say PA and PB, from a common external point, that is to say from point P, that is a common external point, to a circle, to this circle, are equal. That is to say PA is equal to PB. According to rule number 2, the lengths of two tangents from a common external point to a circle are equal. That is to say PA is equal to PB. So whenever you draw two tangents to a circle from a common external point to that circle, then the lengths of those two tangents will be equal to each other. In this case, PA is equal to PB. Okay, so that is the meaning of the two tangents theorem or rule number 2. So we can implement rule number 2 in our drawing, because in our drawing we have the external point C of this semicircle, and from the external point C we have two tangents to this semicircle. The first tangent is tangent CB and the second tangent is tangent CD. Okay, we have tangent CB and tangent CD. And according to rule number 2 or two tangents theorem, the lengths of those two tangents are equal to each other. That is to say, CB equals to CD. Again, according to rule number 2, CB equals to CD. But we know that CB equals to 5 units. It is given us the question. So we can write here that CB equals to 5 units. So from this equation, we will derive that CD also equals to 5 units. Okay, CD equals to 5 units. So I can write here that CD of this seat is the same, equals to 5 units. And what is the value of AD? The value of AD here, AD equals to CA minus CD. I will repeat again. AD equals to CA minus CD. So AD equals to CA is 13 units. It is the hypotenuse that equals to 13 units, the hypotenuse of triangle ABC. And we have already found out that CD equals to 5 units. So in conclusion, AD equals to 13 minus 5, that is to say, it equals to 8 units. AD equals to 8 units. So we can write here that AD equals to 8 units. In the first method, we found out that those two angles are right angles. So I will not repeat on it according to rule number 1. And we know that triangle ADO is a right triangle. So we'll focus on the right triangle, triangle ADO, that is a right triangle, right green triangle. Triangle ADO, that is a right triangle, and we will implement the Pythagoras theorem on the green right triangle, triangle ADO. So in the green right triangle, triangle ADO, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is AO because it is in front of the right angle, so the square of the hypotenuse is AO square, and it equals to the sum of the squares of the perpendiculars. That is to say, it equals to AD square plus DO square. So I will repeat again, in the right green triangle, triangle ADO, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, AO square equals to AD square plus DO square. So we have already found out that AO equals to 12 minus R. Therefore, AO square will be equal to 12 minus R square. And it equals to AD square. AD equals to 8 units. Therefore, AD square is 8 square. 8 square is 64. Plus dO square. dO equals to R, therefore dO square equals to R squared. So in conclusion, we found out that according to equation number 1, 12 minus R square equals to 64 plus R square. We will open the brackets on this side of equation number 1, and we will get that 12 minus R square, it is actually equal to 12 square is 144 plus R square minus 24R, and it equals to 64 plus R square. Okay, here we have R square on both sides of equation number 1, so R square will get cancelled, and what is left from equation number 1 after we cancel R square? What is left? It is actually 144 minus 24R equals to 64. We will subtract 64 from this equation number 1, and we will get that 144 minus 64 is 80. 80 equals to 80 minus 24R equals to 0. We will add 24R to this equation number 1, and we will get that 24R equals to 80. We will divide equation number 1 by 24, and we will get that the radius of the semicircle equals to 80 over 24. Here we will divide both the numerator and the denominator of this number by 8, and we will get that 80 over 8 is 10, and 24 over 8 is 3. So in conclusion, we found out that according to equation number 1, the radius of the semicircle equals to 10 over 3 units. And we will repeat on the same process that we did in the first method in order to find out the area of the semicircle. The area of the semicircle is equal to pi r square over 2. So it is pi, r is 10 over 3, therefore r square will be 10 over 3 square over 2. So it is pi, and 10 over 3 square is 100 over 9, all divided by 2. 100 over 2 is 50, so it is 50 pi over 9 square units, or in terms of numbers, is equal to the area of the semicircle equals to 17.45 square units. Okay, so we actually finished with the second method. In the next step, I will present to you how to find out the area of this semicircle according to the first method. First of all, we have already found out that OB equals to R, AO equals to 12 minus R. Here, DO is also R, and those two angles are right angles. We have already found out that AC equals to 13 units, BC is 5 units and AB equals to 12 units. So in the third method, we will draw a mirror image of this figure, and we will join this figure in its mirror image, and in this way we will get a circle that it is inscribed inside the triangle. So I will draw the combination of this figure with its mirror image. Okay? So actually I combined this figure with its mirror figure, and I actually got this circle that is inscribed by triangle. This triangle will define the vertex here as point D. So we actually, by drawing this the mirror image of this figure and joining this figure with its mirror image, we got here an isosceles triangle, and inside this isosceles triangle there is a circle that is blocked, or this circle is inscribed by this isosceles triangle. BC equals to 5 units, and this is the mirror image of this image, so DB will be also equal to 5 units, and AD will be also equal to 13 units, exactly as AC. So here DC equals to 5 plus 5, that is to say it equals to 10 units. So we got this triangle ADC that blocks this circle, and this is an isosceles triangle. The area of this triangle ADC, will be equal to the base of the triangle, that is actually DC, times the height, that is actually AB, over 2. The height must create 90 degrees with the base, and you can see that AB creates 90 degrees with the base DC. Therefore, AB is the height. So the area of triangle ADC is equal to the base of triangle ADC is DC. Okay, it equals to DC times the height. The height it is given us the question that AB equals to 12 units. So it is actually AB over 2. So the area of triangle ADC is equal to DC. DC equals to 10 units. It is BC plus DB, that is 5 plus 5, times the height, that is 12 units. AB equals to 12 units. It is given us the question over 2. 12 times 10 is 120. 120 over 2 is 60. So we found out that the area of this triangle, the isosceles triangle, triangle ADC, is equal to 60 square units. Okay? The area of triangle ADC is equal to 60 square units. And we know that whenever we have a circle that is inscribed by a triangle, like in this drawing, this circle is inscribed by triangle ADC, then the radius of this circle that is inscribed by triangle ADC will be equal to the area of the triangle that blocks this circle, that is to say the area of triangle ADC, over the semi-perimeter of this triangle that blocks the circle. So it is the semi-perimeter of triangle ADC. So I will write down the formula that will help us to find out the radius of the circle that is inscribed by triangle ADC. The radius of the circle that is inscribed by triangle ADC equals to the area of the triangle that blocks the circle, that is to say the area of triangle ADC, that we have already found out that it is equal to 60 square units, over the semi-perimeter of triangle ADC. And the semi-perimeter of triangle ADC equals to the perimeter of triangle ADC over 2. So the perimeter of triangle ADC equals to AD plus AC plus DC. Again, the perimeter of triangle ADC equals to AD plus AC plus DC, and the perimeter over 2 equals to the semi-perimeter. So we will divide the perimeter by 2 and you will get this, the perimeter of triangle ADC. So the semi-perimeter of triangle ADC is equal to the perimeter over 2. AD is equal to 13 units. AC also equals to 13 units. And DC equals to 10, all divided by 2. 13 plus 13 is 26. 26 plus 10 is 36. 36 over 2 is 18. So we found out that the semi-perimeter of triangle ADC equals to 18 units. And we have already found out that the area of triangle ADC equals to 60 square units. So here, 60 over 18, we will divide both the numerator and the denominator by 6. 60 over 6 is 10, and 18 over 6 is 3. So we found out that the radius of the semicircle, it is actually the radius of the circle, but the semicircle and the circle itself are the same. The circle is the combination of the semicircle. So they have the same radiuses. So the radius of the semicircle equals to 10 over 3 units, and the area of the semicircle is equal to pi r square over 2. That is to say, pi r is 10 over 3 and r square is 10 over 3 square over 2. So it is pi 10 over 3 square is 100 over 9, all divided by 2. And 100 over 2 is 50. So we got 50 pi over 9. So the area of the semicircle equals to either 50 pi over 9 square units, or in terms of numbers, it equals to 17.45 square units. Okay? In the next, we finished with the third method. In the next step, I will explain to you how to find out the area of this semicircle according to a fourth method. Okay? First of all, I will not repeat on the things that we did in the previous methods. So we know that this is the center of the semicircle, that is to say, we defined it as O, OB is R, AO is 12 minus R, AB is equal to 12 units, BC equals to 5 units, and we also know that OD is the radius of the semicircle. This angle is a right angle, and this angle is also a right angle. We did those things in the previous method, so I will not repeat on it. In the fourth method, we will define this angle as angle theta. Angle BAC, we will define it as angle theta. And we focus on triangle ABC, the right big triangle, triangle ABC. Actually, on the right big triangle, triangle ABC, sinus theta, you can see here, on the right big triangle, triangle ABC, sinus theta equals to CB over CA again in the right triangle, triangle ABC, sinus theta equals to CB over CA. We know that CB equals to 5 units. It is given us in the question, and we have already found out that AC equals to 13 units. So in conclusion, we found out that according to equation number 1, sinus theta equals to 5 over 13. I will repeat again. We found out that according to equation number 1, sinus theta equals to 5 over 13. In the next step, we will focus on triangle ADO, the right triangle ADO, or actually the right green triangle ADO. In the right green triangle ADO, sinus theta equals to DO over AO. So I repeat again, in the green right triangle, triangle ADO, sinus theta equals to DO over AO. But we know that DO is the radius of the semicircle, that is to say it equals to R, and AO equals to 12 minus R. So in conclusion, we found out that according to equation number 1, sinus theta equals to R over 12 minus R. In the next step, we will create equation number 2 that states that sinus theta according to equation number 1 equals to sinus theta according to equation number 2. So equation number 3 will be the statement that sinus theta according to equation number 1, that is actually 5 over 13, equals to sinus theta according to equation number 2, that is actually R over 12 minus R. Okay, again, equation number 3 states that sinus theta according to equation number 1, that is 5 over 13, equals to sinus theta according to equation number 2, that is R over 12 minus R. We will cross multiply equation number 3 and we will get that 5 times 12 minus R equals to 13R. We will open the brackets on this side of equation number 3 and we will get that 5 times 12 is 60, 5 times minus R is minus 5R, and it equals to 13R. And we will add 5R to this equation, equation number 3, and we will get that 13R plus 5R is 18R. 18R equals to 60. Here we will divide the equation number 3 by 18, and we will get that R, the radius of the semicircle, equals to 60 over 18. Here we will divide both the numerator and the denominator of this number by 6. 60 over 6 is 10, and 18 over 6 is 3. So we found out that the radius of the semicircle equals to 10 over 3. And therefore, the area of the semicircle equals to pi r squared over 2. That is to say, it is pi r is 10 over 3, so r squared is 10 over 3 squared over 2. That is to say, it equals to pi, 10 over 3 squared is 100 over 2. 10 over 3 squared is 100 over 9, all divided by 2. 100 over 2 is 50 pi over 9. So we found out that the area of the semicircle equals to either 50 pi over 9 square units, or in terms of numbers, it equals to 17.45 square units. Okay, so now I will summarize the lecture. Actually, we wanted to find out the area of this semicircle. We found the area of this semicircle in 4 different methods. In the first method, we actually I presented to you, first of all, we know that OB is the radius of the circle, because O is the center, OD is also the radius, and if OB is R and AB is 12, then AO will be equal to AB minus OB. Again, AO equals to AB minus BO, but AB equals to 12 units and BO equals to R. So in conclusion, AO equals to 12 minus R. We wrote here that AO equals to 12 minus R. And in triangle ABC, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. In triangle ABC, it means that AC square equals to BC square plus AB square. AC square equals to BC square. BC is 5, so BC square is 5 square. 5 square is 25. AB equals to 12, it is given us the question. So AB square is 12 square. 12 square is 144. So in conclusion, we found out that AC square equals to 25 plus 144. 25 plus 144 is 169. So we found out that AC square equals to 169. We took a root out of this equation, equation number 1, and we found out that AC equals to the square root of 169, and the square root of 169 is 13. So we found out that the hypotenuse AC of triangle ABC equals to 13 units. Then I presented to you rule number 1. According to rule number 1, a tangent to a circle is perpendicular to the radius drawn to its point of tangency. So what is the meaning of rule number 1? The meaning of rule number 1 is that if we have this circle and tangent AB is tangent to this circle at point M is the point of tangency of tangent AB with this circle, and we have OM, that is the radius of this circle, and you can see from the drawing that the radius OM, it is drawn to the point of tangency, and because of this fact, the tangent AB will be perpendicular to this radius. That is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. A tangent to a circle, that is to say, tangent AB is perpendicular to the radius drawn to its point of tangency. So whenever you have a radius that is drawn to the point of tangency, like in this drawing, the radius OM, it is drawn to the point of tangency, that is to say, it is drawn to point M, that is the point of tangency of tangent AB with this circle, then the tangent AB will be perpendicular to this radius. That is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. So we can implement rule number 1 in our drawing, because in our drawing we have the radius OD. It is drawn to the point of tangency. Point D is the point of tangency of tangent AC with this semicircle. And we have the radius OD that is drawn to the point of tangency. That is to say, it is drawn to point D, that is the point of tangency of tangent AC with this semicircle. Therefore, the tangent AC will be perpendicular to this radius. That is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. So actually, the green triangle is a right triangle. Triangle ADO is a right triangle. Then we proved that triangle ABC, the big right triangle, and the green triangle are similar to each other. We proved the triangle ABC and the green triangle are similar to each other. Why they are similar to each other? Because of the fact that those two angles, they are both right angles, therefore they are equal to each other. Angle ABC equals to angle ADO equals to 90 degrees. Angle A equals to itself. It is a common angle that belongs to both triangles, so angle A equals to angle A. And we have those two angles that are equal to each other according to third angle theorem. The third angle theorem states that if you have two angles that can congruent to each other in two triangles, like in this drawing, we have those two angles congruent to those two angles. Those two angles in triangle ABC congruent to those two angles in the green triangle. Therefore, the third pair of angles must also congruent. Those two angles must be equal to each other according to the third angle theorem, because they are complementary to 180 degrees. Okay, so we actually found that all three angles in the green triangle can run to all three angles of triangle ABC. That is to say, triangle ABC is similar to triangle ADO. According to angle similarity rule. And from the fact that they are similar to each other, we will conclude that CB over CA in triangle ABC equals to DO over AO in the green triangle. Again, CB over CA in triangle ABC equals to DO over AO in the green triangle. CB equals to 5 units, CA equals to 13 units, DO equals to R, and AO equals to 12 minus R. Here we multiply this equation number 2, and we got that 5 times 12 minus R equals to 13R. We open the brackets in this side of equation number 2, and we got that 5 times 12 equals to 60, and 5 times minus R equals to minus 5R, and it equals to 13R. We added 5R to this equation number 2, and we got that 13R plus 5R is 18R. So in conclusion, we found out that 18R equals to 60. We divided this equation number 2 by 18, and we got that the radius of the semicircle R equals to 60 over 18. We divided both the numerator and the denominator of this number by 6. 60 over 6 is 10, as 18 over 6 is 3. So in conclusion, we found out that the radius of the semicircle equals to 10 over 3 units. And then the area of the semicircle will be equal to pi r squared over 2. So it is pi, r is 10 over 3, so r squared is 10 over 3 squared over 2. 10 over 3 squared is 100 over 2. 10 over 3 squared is 100 over 9. And all divided by 2. 100 over 2 is 50. So in conclusion, we found out that the area of the semicircle equals to either 50 pi over 9 square units, or in terms of numbers, it equals to 17.45 square units. So we finished with the first method. Then I presented to you how to find out the area of the semicircle according to a second method. In the second method, I actually presented to you a new rule. Rule number 2, or 2 tangents theorem. According to rule number 2, or 2 tangents theorem, the lengths of 2 tangents from a common external point to a circle are equal. What is the meaning of rule number 2? The meaning of rule number 2 is that if you have this circle and you have the external point P of this circle, and from the external point P, if you draw 2 tangents to this circle, the first tangent is PA, the second tangent is PB, then the lengths of those 2 tangents will be equal to each other. That is to say, PA equals to PB. So whenever you draw 2 tangents from to a circle from a common external point to the circle, then the lengths of those 2 tangents will be equal to each other. In this case, PA will be equal to PB. We can implement rule number 2 in our drawing, because in our drawing we have the external point C. Point C is an external point in relation to the semicircle. From point B we have the first tangent is CB and the second tangent is CD, and according to rule number 2 they are equal to each other. That is to say, CB equals to CD, but we know that CB equals to 5 units. It is given us the question. CB equals to 5 units. From this equation we will conclude that CD also equals to 5 units. Here CD equals to 5 units. And what is the value of AD? AD equals to CA minus CD. Again, AD equals to CA minus CD. That is to say, AD equals to CA, that is 13 units, minus CD, that is 5 units. So AD equals to 13 minus 5, that is to say, 13 minus 5 is 8, so AD equals to 8 units. AD equals to 8 units. And here in the green right triangle, we implemented the Pythagoras theorem. according to the Pythagoras theorem in the green right triangle, triangle ADO, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, AO square equals to AD square plus DO square. AO equals to 12 minus R. So AO square is 12 minus R square, and it equals to AD square. AD is 8, so AD square is 8 square. 8 square is 64. Plus DO square. DO equals to R, so DO square is R square. And here we open the brackets. On this side of equation number 1, 12 minus R square is 12 square is 144 plus R square minus 24R, it equals to 64 plus R square. We have R square on both sides of equation number 1, so R square will get cancelled, and we left only 144 minus 24R equals to 64. We subtracted 64 from this equation, equation number 1, and we got that 144 minus 64 is 80. So 80 minus 24R equals to 0. We added 24R to this equation, equation number 1, and we got that 24R equals to 80. We divided this equation, equation number 1 by 24, and we got that R equals to 80 over 24. We divided both the numerator and the denominator of this number by 8, and we got that 80 over 8 is 10, and 24 over 8 is 3. So in conclusion, we found out that the radius of the semicircle equals to 10 over 3 units. And the area of the semicircle is equal to pi r square over 2. R is 10 over 3. Therefore, r square is 10 over 3 square over 2. 10 over 3 square is 100 over 9, all divided by 2. 100 over 2 is 50. So in conclusion, we found out that the area of the semicircle equals to 50 pi over 9 square units, or in terms of numbers, it equals to 17.45 square units. Okay, so we finished with the second method. Then I presented to you how to find out the area of the semicircle according to a third method. In the third method, we actually drew a mirror image of this figure, and we combined this figure with its mirror image, and in this way we got a circle that is inscribed by a triangle. Okay? Again, I drew the mirror image of this figure, and I combined this figure with its mirror image, and we got a circle that is inscribed by triangle. Okay? And triangle ADC is an isosceles triangle with the height of AB that is 12 units, AC equals to 13, AD equals to 13, and the base DC it equals to 5 plus 5, that is to say it equals to 10 units. So the area of the isosceles triangle, triangle ADC equals to the base times the height over 2. The base is DC. The height is AB, all divided by 2. DC equals to 10 units. AB equals to 12 units. So the area of triangle ADC equals to 10 times 12 over 2. 10 times 12 is 120. 120 over 2 is 60. So we found out that the area of this triangle, triangle ADC, that blocks the circle, it equals to 60 square units. And we know that the radius of any circle that is inscribed by a triangle, like this circle that is inscribed by triangle ADC, will be equal to the area of the triangle that blocks the circle. In this case is the area of triangle ADC, that is 60 units, over the semi-perimeter of the triangle that blocks this circle, that is to say over the semi-perimeter of triangle ADC. And the semi-perimeter of triangle ADC equals to the perimeter of triangle ADC over 2. I will repeat again. The radius of the circle that is inscribed by triangle ADC equals to the area of triangle ADC that blocks the circle over the semi-perimeter of triangle ADC that blocks the circle. We have already found out that the area of triangle ADC equals to 60 square units, and the semi-perimeter of triangle ADC equals to the perimeter of the triangle over 2. The perimeter of triangle ADC equals to AD plus AC plus DC, and we divide it by 2 in order to get the semi-perimeter. AD is 13, AC is 13, and DC is 10. So it is the semi-perimeter equals to 13 plus 13 plus 10, that is 36 over 2. So we found out that the semi-perimeter of triangle ADC equals to 18 units, and the radius equals to 60 over 18. We divided both the numerator and the denominator of this number by 6. 60 over 6 is 10, and 18 over 6 is 3. So we found out that the radius of the semicircle equals to 10 over 3 units, and the area of triangle, the area of semicircle, of the area of the semicircle equals to pi r square over 2. R equals to 10 over 3, so r square will be equal to 10 over 3 square, all divided by 2. 10 over 3 square is 100 over 9, all divided by 2. So in conclusion, we found out that the area of triangle, the area of the semicircle is equals to either 50 pi over 9 square units, or in terms of numbers, it equals to 17.45 square units. So we finished with the third method, and then I presented to you how to find out the area of the semicircle according to a fourth method. According to the fourth method, we defined this angle CAB is theta, and we focus on the right triangle ABC. In the right triangle ABC, sinus theta equals to CB over AC. Again, in the right triangle ABC, sinus theta equals to CB over AC. CB equals to 5 units, CA equals to 13 units. So in conclusion, we found out that according to equation number 1, sinus theta equals to 5 over sinus theta equals to 5 over 13. Then we focused on the green the green right triangle ADO. Here, sinus theta equals to DO over AO. In the right triangle ADO, the right green triangle ADO, sinus theta equals to DO over AO. DO equals to R, AO equals to 12 minus R. So in conclusion, we found out that according to equation number 2, sinus theta equals to R over 12 minus R. But we know that sinus theta according to equation number 1 equals to sinus theta according to equation number 2. So we created equation number 3 that states that sinus theta according to equation number 1, that is 5 over 13, equals to sinus theta according to equation number 2, that is R over 12 minus R. Okay? We cross multiplied equation number 3, and we got that 5 times 12 minus R equals to 13R. We open the brackets on this side of equation number 3, and we got that 5 times 12 equals to 60, and 5 times minus R equals to minus 5R. Here we added 5R to this equation number 3, and we got that 13R plus 5R is 18R. 18R equals to 60. We divided equation number 3 by 18, and we got that R, the radius of the semicircle, equals to 60 over 18. We divided both the numerator and the denominator of this number by 6, and we got that 60 over 6 is 10, and 18 over 6 is 3. So we found out that the radius of the semicircle equals to 10 over 3 units, and then the area of the semicircle equals to pi r square over 2, r equals to 10 over 3, so r square equals to 10 over 3 square, all divided by 2. 10 over 3 square is 100 over 9. So all divided by 2. 100 over 2 is 50. So in conclusion, we found out that the area of the semicircle equals to either 50 pi over 9 square units, or in terms of numbers, it equals to 17.45 square units. Okay? Thank you very much.